So hello, everyone. I'm aware that I'm the last person between you and the drinks and refreshments. I will try to be respectful of that. So for the past 6 weeks, so I'm André Richter. And for the past 6 weeks, I've had the pleasure of working with the London Fire Brigade on a fire engine staff optimization project. So to give you a little bit of background, I guess you know who the London Fire Brigade is and what they do. What you may not be aware of is that they attend about 100,000 incidents of fires each year. And they do so, on average, within 6 minutes. Within 6 minutes, the first firefighter arrives at the scene of a fire. Now, given that this is London, how do you do this, right? How do you get anywhere within 6 minutes? So one part of the answer is that they maintain about 100 stations at strategic locations all across London. And these locations allow them to quickly and effectively reach any point in London in a given amount of time. However, it's important to understand that their ability to quickly respond hinges on each and every station to be fully operational. And fully operational means that the fire engines can immediately be deployed that are at each station. You've probably seen fire engines before. Probably you passed them once or twice, or they passed you, to be more precise. What you may not be aware of, that these fire engines are packed with appliances and an array of equipment that are all highly specialized. So once I started with this project, I came to think of a fire engine as a Swiss Army knife, but not like this one, more like this one. So what do you think is wrong with this Swiss Army knife? Well, I think no single individual can handle it. And the same is true for a fire engine. The sophistication and the complexity of a fire engine comes at a cost, namely that you can't really handle it if you don't have specialized knowledge. So in principle, firefighters are, in some sense, experts on some domains. So to give you an example, you can't just drive a fire engine, a humongous truck, at full throttle through the inner city of London. You need to be specially trained to do so. And obviously, not every firefighter can have all the skills required to operate a fire engine. Do you understand the situation? Yeah. So, and this exposes a vulnerability. What happens if one of your team members who has a certain skill that is required to operate the fire engine is not there? I mean, life happens. You're sick. You miss a train. You miss a plane, whatever. And then the firefighter doesn't show up for work. And this, unfortunately, happens every day. And then when this happens, the fire engine cannot be used, and the headquarters gets notified and tries whatever it can to find a different firefighter, a spare firefighter, across London to fill that vacant spot so that they can use that fire engine and that station again, to protect London from fires. So right now, this is a very manual and tedious process, and it is very reactive. The headquarters basically calls up people after they have been informed that a fire engine is, as they call it, off the run. Now, the basic idea of my project is, can't we do something more, let's say, proactive? Can't we predict the bad outcome before it happens so that we can potentially prevent it, or at least adjust appropriately? And this is part of my project. I've created a classifier that takes the data from the London Fire Brigade, combines it with a machine learning algorithm, and twists it based on a couple of insights that we generated from just interviewing people at the fire brigade from all different levels, from the senior management to actual firefighters, to get a prediction of where and when a fire engine will not be able to be used due to understaffing. Now, how well does my prediction do? The best model that I was able to find was an ensemble classifier, and it manages to correctly classify 72% out of all the staff shortages. That means if tomorrow there are 10 stations that have problems with their fire engines, so there's not enough people to operate the fire engines, the predictions of my model capture 7 of these. So I think this can be used. This will help the fire brigade to better allocate the resources in the future. And eventually, it will help to keep more fire engines on the road and to make London a safer city. Thank you.